It is time to begin now. Hey, thanks for coming. I am so glad you're here. I'm David Calhoun, director of both the Gonzaga Faith and Reason Institute and the Gonzaga Socratic Club, the organizations that are co-sponsoring today's event. Both organizations broadly address faith and reason issues from a philosophical perspective. The Faith and Reason Institute, as the name suggests, seeks to develop an integrationist understanding of faith and reason, particularly as they are articulated in the Catholic intellectual tradition and found in issues such as faith and science, philosophical theology, and reflection on faith, evil, and suffering. I would like to begin our event this afternoon by thanking Gonzaga University and President Thane McCullough for supporting the Gonzaga Faith and Reason Institute throughout the years through the Father Robert J. Spitzer Society of Jesus Leadership Fund, of which the Faith and Reason Institute is the primary beneficiary. Hundreds of friends of the university and a former president, Father Robert Spitzer, have contributed to this fund over the years, making possible public events such as the one today. The Institute is deeply grateful for their support and indebted to all of them for the gifts that make events like today's talk possible. The Faith and Reason Institute's particularly interest in faith-science integration is the focus of today's event. Our speaker today is Brother Guy Consolmagno of the Society of Jesus, director of the Vatican Observatory, which sometimes leads to him being given the affectionate moniker, the Pope's Astronomer. Brother Guy is a planetary scientist with degrees from MIT and the University of Arizona, with a research focus in asteroids and meteorites. He was just telling us, as a matter of fact, that he had barely had a chance to handle or touch very many meteorites until he got to the Vatican, much after his initial studies, where they actually have a collection of meteorites to study and to analyze. Brother Guy entered the Society of Jesus in 1989 and took vows as a Jesuit brother in 1991. He has taught and researched at institutions including Harvard College Observatory, MIT, Fordham University, LeMoyne College, and the Goddard Space Flight Center. He was assigned to the Vatican Observatory in 1993. Brother Guy has authored and co-authored books and articles on astronomical science and several books on faith and science issues, including Brother Astronomer, God's Mechanics, and the intriguingly titled, Would You Baptize an Extraterrestrial? Today, Brother Guy will be sharing with us about the rich history of astronomical history associated with the Vatican. Please join me in welcoming Brother Guy for his talk, Astronomy and the Vatican.
I'm glad you could all make it. I thought I'd start with a little bit of scripture that's, appropriate for this kind of talk. O Lord, how sovereign, how majestic your name in all the earth. You've set your glory above the heavens. When I look at your heavens, the work of your fingers, the moon, the stars you've established. What are human beings that you're mindful of them? Mortals that you care for them. And yet you've made them a little lower than God and crowned them with glory and honor. The idea that the universe is enormously big and we're really tiny is not something that comes out of modern science. The psalmist knew that. Astronomy in ancient times understood that the universe was big. If they didn't have the same numbers we've got, after a while, big is big. It doesn't really matter. And there's two ways of looking at this fact. You can say the universe is so big and I'm so small, God couldn't possibly be noticing me. Or you could say the universe is so big and I'm so small, how enormous God must be to be able to notice me and you. Not sure about you, but you. Either way, astronomy has this powerful religious call to make us understand who we are and how we fit in the universe. The prophet Baruch put it this way, O Israel, how great is the house of God, how vast the territory he possesses. Who's gone up to heaven and taken her and brought her down from the clouds? And later the prophet writes, the stars shone in their watches and were glad he called them, and they said, here we are. They shone with gladness for him who made them. This is our God. No other can be compared to him. So if you worry that, our God isn't big enough to accept extraterrestrials, here we've got the prophet Baruch talking about stars themselves, glorifying God. Is it poetic? Doesn't really matter at this point. It shows that we recognize the God who created us as the God who created the entire universe. In fact, there are at least 3 axioms that you have to accept which are religious in nature before you can do science. Every logical system starts with axioms, starts with assumptions. I can prove anything if you allow me to give you the axioms we're going to start with. The first thing is you assume there is a real universe. It's not just a dream. I'm not just a philosopher dreaming that I was a butterfly or a butterfly dreaming I'm a philosopher. I have to believe the universe is real. I have to believe that the universe follows laws. And you say, well, of course, that is such an assumption baked into our society. Plenty of rooms down here, by the way, if you guys are looking for a place to sit. I didn't mean to chase you away, sorry. I mean, this is so baked into the way we look at the universe that it's hard to remember. The ancient Greeks, the ancient Romans didn't think that the universe ran by laws. They thought that, the universe was run by nature gods. You want to get things out of it, you got to appease the nature gods. Once you say there are no nature gods, then you've got to say, okay, if Thor didn't throw the lightning bolt, if Jupiter didn't throw the lightning bolt, then where the heck did the lightning bolt come from? That is a religious assumption, essential to being able to be a scientist. If you don't believe that the universe is real, what is there to study? That is an assumption that, is religious in nature, because not all religions will tell you that. And finally, you have to believe that the universe is good enough that it's worth spending your time finding out what those laws are. And remember, I'm not talking technology. I'm not talking about making, better medicine or better iPhones. I'm talking about trying to figure out, was there a Big Bang? Why would a grown human being spend their life worrying about that if the universe wasn't worth worrying about? There are people who will tell you that chocolate is the temptation of the devil to give you acne and make you fat. And we should meditate ourselves to a higher level so that we no longer care about chocolate. But my religion tells me that chocolate is a foretaste of the goodness of God. And it's almost a sacramental. Which religion do you want to belong to? If you don't believe in these religious principles, you don't have the reason to be a scientist. In astronomy in particular, you notice that before you could get your PhD or your THD in the medieval universities, you had to take the trivial courses, you had to go to grammar school to learn grammar and rhetoric and dialectic. And then you had to have the quadrivium courses, arithmetic and geometry and music and astronomy. These, before you could go on to get a doctorate. Of course, that's the medieval university, and we don't live in a medieval world anymore, so that my degree isn't certainly a doctor of philosophy. Well, actually it is. But I didn't dress up in a funny medieval outfit with a funny hat to get my... Well, actually I did. Astronomy, from the beginning, was something about how the universe is put together. A lot of seats up here, by the way. Come on down, I'm not going to feel insulted. Plenty of seats here. Astronomy, of course, was really important to ancient people because it was a way of keeping time. And we all probably know how, the date of Easter was set. We've just celebrated. It was the first Sunday after Passover. What's Passover? Passover is the first full moon of spring, so you have to know where the moon is, hence making a calendar of months. We now say months. And we have to know when spring was, so we had to have a calendar that kept track of the seasons. And the seasons, of course, involve stars. You have winter stars, and the winter stars will tell you when it's time to do winter things, and spring stars, time to do spring things. The month of August, you can calculate that the sun rises with the dog star, Sirius. That's why those are called the dog days. And if you believed in the culture of the time, the cosmology of the time, those stars were probably giving some kind of influence to us here down on Earth. Sometimes good, sometimes bad. I notice every winter I tend to get sick. It's probably due to the influence of those nasty winter stars. You laugh. Why do you still call it influenza? Where do you think the word came from? Italian for influence. By the time of Pope Gregory XIII, it was obvious that the calendar that had been set up by Julius Caesar that had both months, and years was getting out of whack. And as a result, they hired a bunch of astronomers to figure out how to make the calendar better. Among those astronomers was Christopher Clavius. There's a crater on the moon named for him. Pretty cool guy. Clavius was the mathematician who invented things like the decimal point and grouping terms together in equations. He wrote the math books that were used across Europe for 100 years. I won't go into the whole reform of the calendar. That would take, more time than we got here. It's a really interesting story. Well worth looking up. The point is that it was the church who did the reforming, because the church would use the calendar as a way of keeping track of when feasts were. When they decided that they had to eliminate 10 days from the calendar in 1582 to make the seasons line up again with the dates in the calendar, they chose 10 days that didn't have any feast days in the middle of October. Very clever of them. They also used the calendar to determine when the dates of Easter were going to be. This was important because you could no longer say simply the first Sunday after Passover. What if it's Sunday in one part of the world and Saturday in a different part of the world? Because we've got missionaries now in South America, and missionaries now in Taiwan, and missionaries, Christians around the world. What they came up with was an arbitrary formula that kind of gets it right 16 years out of 18, or 15 out of 70, something like that. The deeper principle was that our religious holidays are when we decide they're going to be. And for reasons of history and culture and continuity, we like to imitate, but we don't have to be slavishly following. That's why, Passover was this full moon, but Easter was a month ago, after the other full moon. Sometimes they line up, sometimes they don't. The Sabbath was made for man, not man for the Sabbath. Which incidentally means that when we go to Mars, we don't have to worry about which moon is full. Mars has 2 moons. We can make Easter whenever we want it to be. Part of the reform of the calendar, of course, was convincing people that the calendar needed to be reformed. So at the time of Gregory XIII, this tower was built on one of the wings of the Vatican. It's actually above where the Vatican Library is now. And that's what the tower looks like today. It's several stories tall. And one of the rooms was called the Room of the Winds, and since this is now called the Tower of the Winds, there were paintings of the winds on the 4 walls. On the south wall, there is this little putti is a plural, so I guess it would be puto, blowing the wind. And his mouth is an open hole, and sunlight will come through that hole, and as the seasons change, the place where it crosses that center line will move from one side to the other. And from this, you can understand how you can then determine what are the extremes, the shortest day of the year, the longest day of the year, and the point in between would be the first day of spring and first day of fall. I'll tell you a little secret they don't want you to know. It's really there. I've been to that room. But it really doesn't work the way you'd want it to work. To make it work, you have to be able to see the shortest day and the longest day. The shortest day of the year is when the sun is really high. The hole is not aimed so that sunlight gets through. From about the middle of May until the middle of July, the sun doesn't get through the hole. The longest day of the year is when it's really low. The room is so too small, the sunlight spot actually lines up on the far wall. They did build buildings that had this full sweat. This was simply a PR gimmick to show people kind of what they were doing so that they could excuse why they had a change of the calendars. Not the first time astronomy is used for PR. Well, there's Christopher Clavius, and there is a page, because once you've got the arbitrary definition of Easter, you can then calculate with that formula up to the year 5000 and beyond, and in his book he includes up to the year 5000, including when is Easter in 2024? The 31st of March. When will it be next year? The 20th of April. And it goes up to the year 5000. So those of you who thought that the world would end when the Inca calendar ran out, we're good to the year 5000. All of this was done in the 1580s. Among the astronomy that they used were the wonderful tables and calculating devices that Copernicus had come up with. Copernicus published his book in 1542. Copernicus was no problem to the church. They used it to reform the calendar. Nobody thought that Copernicus was, heretical by saying that the sun goes, standing still and the earth goes around the sun. If you know your history, what happened the same decade that Copernicus publishes his book? The Council of Trent opens. They spend 18 years finding heresies everywhere, and nobody ever worries about Copernicus. 80 years later, Galileo comes along, and he gets in trouble. Put this in perspective. This is the year 2024. In the year 1624, Galileo starts writing a book that's going to get him in trouble, in 2031. Based on a theory that was published back when World War II was going on. So it's not like these are radical new ideas that Galileo was talking about. Galileo, of course, sees the moons of Jupiter, sees spots on the sun, sees all sorts of fabulous things that were never described in ancient books. And he was bright enough to understand and know what he was seeing. And he was a good enough writer so that everybody else knew about this. Galileo's book comes out in 1610. It's published like within 4 months after he makes the discoveries. Boy, I wish I could publish that fast. Within 2 years, Shakespeare is writing a play, Cymbeline, where there is a character named Jupiter who has 4 attendants going around him when he shows up on stage. That's what a big deal Galileo was. Galileo, of course, was not the only person doing astronomy. Christopher Scheiner had a telescope, and he also saw sunspots. And Galileo was really, really mad that this Jesuit was, stealing his thunder. And Scheiner was really mad that Galileo was mad at him because, who was the first guy to actually see sunspots? It was a fellow named Thomas Harriot, who found them a year before either of those guys. There were also a couple of German astronomers who published ahead of time. But this jealousy about who was first, thank heavens nobody worries about in modern science today, priority and who gets their name attached to things. Well, maybe. I'm not going to make this a Galileo talk. I just want to point out 3 things about Galileo that they never tell you. when they say, oh, Galileo was crushed by the church and showed that the church was anti-science. Galileo himself was a devout Catholic before, during, and after his trial. He had 2 daughters, and they were both nuns. Of course, he never married their mom. He was an Italian Catholic, but still. He could have fled to the north, to the Protestant north, except they were even more against this crazy idea than the Catholic world was. Galileo was actually never convicted of being a heretic. The first time he was called in for his dangerous ideas, Cardinal Bellarmine writes a letter saying, if anybody calls you a heretic, show them this letter that I have written that states, Galileo, you are not a heretic. This is your get out of jail free card. Galileo writes more papers and more books for more than 20 years, including a book that is passed by the Pope's censors, that the Pope knows well. The Pope knows Galileo well, they're best of friends. The Pope, Urban VIII, actually writes a long poem of praise about Galileo and how wonderful he is and how glorious it is to look through one of Galileo's telescopes and see the moons of Jupiter. They never tell you that. And then in 1632, for apparently no reason, the Pope is shocked to discover what Galileo is saying in this book that he had approved the year earlier. What's going on? There are more theories about what's going on than there are theorists. It was a tragic conflict of worldviews. Well, how can worldviews be conflict? He was a secret person who believed in atoms. Then how come that's never mentioned at the time by anybody talking about Galileo, any of the letters? He made too many political enemies. Of course he made political enemies. He was an Italian. That's what we do. The philosophers are out to get him. The Jesuits are out to get him. At one point during the trial, the Jesuits said, if he'd stayed friends with us, this would never have happened. And Galileo said, aha, I knew it. It was all your fault, which is not really what the guy meant. His book personally insulted the Pope. And there's a way you can read it where, it kind of looks that way. But then there's another way you can read it where he says, no, actually, that's not what he was doing. My favorite theory, which I got from a historian of science at Yale, but a lot of other people disagree with completely, was that it was tied up with the 30 Years' War. The 30 Years' War reached its climax. The war between the Protestant north of Germany and the Catholic south of Germany reached its climax the very year when suddenly Galileo was put on trial. And that was the year when the Pope was under enormous pressure because he wasn't supporting the Catholic South. Because in fact he had been elected with the power of France, which was actually supporting the Protestant North, because it wasn't a war between Protestants and Catholics. It was a war of everybody against Spain, who was too powerful, they thought. And the Holy Roman Emperor, who was related to the King of Spain. And Galileo was a creature of the Medici family, where Florence at that time was being run by the Duke's mom, who was a sister of the Holy Roman Emperor on the Spanish side, and his grandma, who was a daughter of the king, granddaughter of the King of France. It was all tied up, maybe, in that, maybe. Or maybe there's but whatever it was not a science versus faith issue. We talk about it in this book with the subtitle is no longer Strange Questions. I was going to call it Stupid Questions. But it's just the questions that people will ask us. They ask us about Galileo. I wrote an incredibly much too long chapter in this book, which Paul Mueller kept pulling me back and saying, well, no, what about this? What about that? And he argues one side and I argue a different side. And the point is, we don't know. But you can read the transcript of the trial. And it is not some Scopes trial where he's standing for science against the evil church. It's Galileo saying, tell me what I did wrong and I'll fix it. And them saying, no, we've got to find you guilty of something. And when the verdict came back that said, we find you guilty of heresy, Galileo says, no, you didn't. Number one, I've got this letter from Bellarmine saying I'm not a heretic. And number two, you haven't identified the heresies. And so they change the thing he was found guilty of. He was found guilty of vehement suspicion of heresy. Where it sounds to me like the person committing the crime is the suspector, not the heretic. And when Galileo gets up and abjures and denies, he says, I condemn and abjure and deny anything in my writing that is contrary to the teaching of the church. And he never points out what any of those things might be. And they let him get away with it. And he goes back to his home on a farm outside of Florence, and he writes more books, and he has more visitors, and he dies peacefully in his bed. Not only is the Galileo story not what you're told, it's also not a case of modern science being suppressed, because if you read the other scientists of the day, which a lot of people haven't bothered to do, but my buddy Chris Graney has finally translated into English, you find out that they have really good reasons to say, yeah, I like the Copernican system, but it doesn't work. You know, if the Earth was spinning, says Riccioli, 20 years after the Galileo trial, if the Earth was spinning and you were to fire a cannon due north, the momentum of the cannonball would have an eastward momentum because of the Earth turning to the east. But as you go further north, the ground under you is not moving to the east quite so fast. By the time you get to the pole, it's not moving at all. Therefore, the path would have an apparent curve towards the east. And the physicists in the room go, yeah, that's called the Coriolis force. This was 200 years before Coriolis worked it out. Riccioli's right. And then Riccioli says, nobody's ever noticed that, so I guess the Earth isn't turning. Rather than saying, this effect is so tiny that there's a zillion other things that would swamp it, which is why we haven't seen it. But they didn't know that at the time. And just to realize that, Riccioli was no slouch, he also made the first map of the moon with the modern nomenclature where we call seas, seas, and oceans, oceans, and mountains, mountains, and craters are named after prominent scientists. And even though he concludes that Copernicus was wrong, he still names the most prominent crater on the moon after Copernicus. And Kepler and Galileo and Aristarchus also get craters, even though they believed in the heliocentric system. He also names craters for himself and his student Grimaldi and another 24 Jesuits. The idea of using that spot on a wall to look at a spot on the ground to measure the position of the sun and work out the seasons was maybe not done in that tower, but it absolutely was done in cathedrals. If you go to churches across Italy and France to this day, you will find on the ground these various lines with the different astrological symbols and a hole in the south wall, which sometimes is still open. And you can see, not only were they measuring where was the sun, they were measuring how big was the dot and does it change over the year. And the answer is, you can't tell because of the wave nature of light, it's not sharp enough. They didn't know that. They were trying. Cassini worked this out in 1655, eventually went to France, measured the map of France, because you can work out with these sort of systems, both the latitude and the longitude, of where every cathedral was. He made the first accurate map of France, presented it to the King of France, who said, according to this map, France is a lot smaller than I thought. You've lost me more territory than I've lost in all of my wars. But the point is, big-time science continues to be done in the Catholic world. And you will find books, mostly written in England, saying, oh, after Galileo, science stopped in the Catholic world. Then who the heck was Cassini? Who the heck was Volta, the guy we named Volts for? Good Catholic Italian. Who the heck was Jean-Pierre Ampère? Jean-Marie Ampère, the guy who would get amps from. Devout French Catholic. Who the heck was, Gregor Mendel, the monk who came up with genetics? And yet you will find people saying that the church is anti-science. I'll give you another example, another good Jesuit, Roger Boscovich. He taught Newtonian physics in the Jesuit schools. He observed the transits of Venus, of Mercury. He worked out how to refix the dome of St. Peter's. He was the one who made sure that the church said you can teach heliocentrism as a philosophical point. And that really took Newton's physics before the rest of the world accepted, okay, maybe the sun really is standing still. And it took Kepler's orbits, which it took a long time for the rest of the world to accept. He also was the guy who came up with the atomic theory. Supposedly the reason why Galileo was, come on, the Jesuit, he came up with the modern atomic theory. Incidentally, before him, they were still teaching Copernicus in the Jesuit schools as a way of calculating planetary positions. They're just saying, well, we're not sure if this is actually how the universe works, but the math works. By 1760, you've got this marvelous ceiling in the Jesuit college in Prague, where our little students, I hope you don't dress like that anymore, are using telescopes to look at stars where every star is surrounded by planets and comets. You will still find people who say, oh, the church doesn't believe in the Copernican system until 1992 when they forgave Galileo. Explain this. At the Vatican Observatory in the 1930s, the Vatican libraries decided to make room in their shelves by dumping on us all of their modern science books. By modern, I mean printed with a printing press. I happened to grab this copy of the Philosophical Transactions, giving some account of the ingenious undertakings in many parts of the world. I picked this one, frankly, at random, just to see who is writing science papers in 1735. Well, there's a medical doctor. Well, there's a minor nobleman. Well, there's a German, we don't know much about him. There's a sea captain, and then there's the Reverend de Fadlier, and then there's, who's also a lawyer, and then there's another nobleman. Finding clergymen writing scientific papers is very common. In those days, who had the education and the free time and the inclination to do science? There was no government grants to do it. But if you had, a church that gave you a nice income and not much to do during the week, that's true about parish priests. You don't have much to do during the week. No, not really, no. But think of what is the work of a typical scientist. You're gathering leaves and you're sorting and classifying them. You're looking at stars and you're sorting and classifying them. You're looking at bugs and you're sorting and classifying. When I was a kid, you would do that on little 3x5 cards. Nowadays, we use Excel spreadsheets. Same idea. It's clerical work. That's really what a lot of science is. Why do they call it clerical? Because it was done by clerics. If science is being done by clergymen, why does anybody think that the church is anti-science? Let me tell you about a Jesuit scientist, probably the greatest scientist you've never heard of, Angelo Secchi. He did a number of wonderful things I don't have the time for. Among them, anybody here ever been to Rome? And you've been to the Church of St. Ignatius in Rome? And this is this wild church that you go inside and you see the dome over the altar and it kind of looks dark and you go, well, why don't they put some lights up there? And then you walk a little bit further and you realize the dome is falling on me. Until you realize it's a flat ceiling. They painted the dome in perspective because they ran out of money and never put the dome up. So there are these 4 pillars to support the weight of a dome. Secchi puts telescopes on top of those pillars on the roof of the church. From there, he observes the sun. He makes the first photographs of a total eclipse, and he sees that the corona in his photograph match the corona seen in photographs taken elsewhere to show that the corona is actually attached to the sun and not just a phenomenon of the atmosphere where he's standing under. This connection between the corona solar activity and magnetic fields on Earth that he traces out turns out to be so important to us today that NASA has a couple of spacecraft measuring the Sun-Earth connection coronal and heliospheric investigation. There's fame, to have your name turned into a NASA acronym. I'm waiting for them to do that with Consolmagno. The greatest thing he did, though, was to put a prism in the light path of his telescope, and from that, look at every star not as a point of light, but as a spectrum, finding the lines that mean we can tell what chemicals are in those stars, and noticing that of the 5,000 stars he measured, you can classify them into 4 or 5 or 6 different groups. That's the beginning of the Hertzsprung-Russell diagram. That's the beginning of astrophysics. He was also the first person to look at Mars, not to measure out where it is in the sky, but what are those things on the surface? He invents astrophysics, he invents planetary sciences. He dies in 1877, same year that the Pope Pius IX dies. The Pope after him, Leo XIII, has a big celebration for his Jubilee, and among the things in the celebration, well, there's this bust of Angelo Secchi. The guy who organized it was one of Secchi's students. But there are all sorts of astronomical and scientific instruments that are put together by the clergy in Italy, because science is still being done by the clergy in Italy. But now we're at the end of the 19th century, and there are 2 really important problems that Leo XIII is facing as a pope. First of all, the Italians have conquered everything except the land around the Vatican, and they no longer recognize the Vatican as an independent country, but he wants to still be independent and the Pope should not be, the subject of the king. Well, furthermore, there are other countries that don't like Italy who are happy to go along with this. So the French are organizing an international project involving telescopes. The Vatican says, hey, if we have a national observatory, can we be recognized as a nation separate from Italy? And the French said, yeah, we'll go along with that. But there was something else going on at the end of the 19th century. Remember, everything I've shown you up to now are the clergy and the church working with science, doing the same science as everybody else, publishing in the same places as everyone else. And suddenly, at the end of the 19th century, the Italian government puts up this statue to Giordano Bruno, the martyr to science who was burned at the stake because he believed in, that every star was a sun. Actually, there was a cardinal 200 years before him who said the same thing. Maybe he was burned at the stake for plagiarism. If you read about Giordano Bruno, you say, okay, no, people should not be burned at the stake, but it wasn't for his science. He wasn't a scientist. He was a charlatan magician. He was a nasty piece of goods who was run out of every city in Europe, Catholic and Protestant. And there was a reason why people finally got fed up with it. But the Italian government decides that he's a hero, along with Galileo. Look what the church did to Galileo. In America, there's this marvelous book, The History of the Warfare of Science with Theology. Andrew D. White. Andrew Dixon White, the guy who founded Cornell University. It is your duty to make sure whenever your teams play Cornell that you win. Basically, he is writing a long screed that said, everything the good that happens in the world happens because of science. Everything bad that ever happened because of the church. And here's all the places where the church tried to suppress science. Well, look what they did to Galileo. And everything that you've heard about Galileo, which isn't true, you'll find in this book. I'll give another example. Interesting question. We got people of different ages here. Most of you were probably born and raised in the United States. Yep. How many of you guys were ever taught that Christopher Columbus proved the world was round? A few of you. In my generation, we were all taught that. Utter nonsense, of course. He didn't even make it around the world. It's in this book that the church believed that the world was flat and he would fall off the edge, but Columbus proved that it was round. Well, he didn't prove it was round. The church didn't think it was flat. It's utter garbage. But it's garbage that got its way into the popular press, into the Sunday supplements, their version of cable TV. And to this day, there are, you watch Neil deGrasse Tyson's Cosmos, and it's still repeating the same goofy stuff that this guy invented. Why was this guy so down on the Catholic Church? Because he didn't want people with vowels at the end of their names coming into America. Keep the immigrants out of here, like my grandfather. Obviously ruined the place. The anti-immigration mania finally resulted in a law passed in the 20s that dropped Italian immigration by 90% and made sure that it was impossible for any Asian to come to America at that point. And that law was not repealed until the 1960s. But even worse than that, to prove that the church was anti-science, I'm doing the time, I'm going way past, nonetheless. To prove the church was anti-science, the church is so foolish as to speak out against the grand thing that will make the human race perfect by cleverly breeding the proper people and sterilizing those who are inferior. Only the church spoke out against eugenics. People got the idea of eugenics by misreading or actually not reading Darwin. Darwin doesn't talk about it, but, oh, survival of the fittest. That means that I'm surviving. If I'm rich, it must be because I'm more fit than you. And if I'm just naturally better than you, then obviously a waste of my time to try to educate poor people. What good are they? Besides, they all look funny. They got red hair and freckles. We all know how stupid the Irish are, and I can even explain why. All the smart Irishmen become priests. And so it's only the dumb ones who have families. My mom's Irish, by the way. This is the kind of garbage. I had a friend who worked at the Museum of History in Buffalo and got into the storage rooms where he found this kind of crap on big displays that used to be part of the Natural History Museum. Not only in Buffalo, but in museums around the world. And when the church speaks out against this, everybody says, oh, you're just standing in the way of progress. So the Pope, Leo XIII, decides we're going to have a national observatory, both so he'll be recognized as a nation, but also to say, no, we actually support science. Angelo Secchi, made our reputation in astronomy, so we're putting telescopes on the various parts of the wall around the Vatican. There is even this 1929 film, newsreel, talking about the Vatican and its telescopes. Hidden away in a secluded corner of the Vatican, the Great Observatory. And the movie goes on and on and on. I've been talking too much. This is the telescope that was used to photograph the sky when we were interested in trying to show that the Vatican was an observatory and part of this Photograph the Sky program. The photographs were then measured. Every star position on a photograph was measured by computers. Computers in those days being women. These were sisters of the child Mary. The convent actually wanted to make sure that no real sisters were used, so they had novices do this kind of work. Over the years, however, the Vatican's attitude to astronomy changes in an interesting way. Leo XIII wants astronomy because it'll make the church look good. Pius XI says, actually, astronomy is good because it inspires people to pray. It's more than just making us look good. It's actually, it got a religious usefulness. At that same time, Georges Lemaitre, a priest from Belgium, is coming up with the idea of the Big Bang Theory. You recognize him with the familiar looking collar. By the 1930s, finally, Italy and the Vatican have come to an agreement, and the territory out in Castel Gandolfo, where the popes had their summer homes, are given back to the Vatican, and the Vatican decides, all right, the church Italy accepts that the Vatican is a nation. Do we need an observatory anymore? Yeah. They decide to rebuild an observatory with telescopes on the roof of the Papal Palace. Those were the offices when I arrived there in 1993. That was my office in particular. That was the Pope's summer bedroom. You're looking at the one guy in the church who was above the Pope. At that time, a group of young Jesuits from Germany were installed in the palace to create an atlas of spectra, so that it's not enough you get the spectra of a star. We now know the spectra of every element, because these guys measured it in a lab and published it and started a journal that's still being published today called Spectra Chimica Acta. After the war, new telescopes are installed in the gardens, including this new modern Schmidt telescope. Pius XII is the one who actually paid for the telescope. And he says an interesting thing. He notes, man ascends to God. Man ascends to God by climbing the ladder of the universe. It's not just that astronomy makes the church look good. It's not just that astronomy makes you pray better. It's that astronomy itself can bring you to God. And he's only echoing what's in Paul's letter to the Romans, chapter 1, verse something or other, 21, 22. Since the beginning of time, God reveals himself in the things he's made. John the 23rd came and visited the place. Paul the 6th was there when we installed the first computer at the Vatican. And he was also there when people first landed on the moon. By the time I arrived, that's the skinny guy with the red and black hair off in the corner there. That was a while ago. The fellow next to me, Bill Stager, was a wonderful California province Jesuit who sadly died of cancer about 10 years ago. And of course, Pope John Paul has died. The fellow with the gray hair, the oldest in the picture, is Sabino Maffeo. He turns 103 this year. He's still going strong. But notice what John Paul II said about science. Science can purify religion from error and superstition. Religion can purify science from idolatry and false absolutes. He says in his marvelous encyclical about faith and reason, that faith and reason are like two wings that carry us to truth. Faith is not the goal. Science is not the goal. It's the tool that brings us to the real goal, which is truth. This gives science a status equal to that of faith by a pope. The laws of nature are a great incentive to contemplate the works of the Lord with gratitude. Scientific research can and should be a source of deep joy. But in Laudato Si, Francis also makes the point that science is done by human beings. Faith is done by human beings. The human person is the place where faith and science are so mingled they cannot be separated. It is the decisions that we make based on nothing more than gut instinct and experience that make us choose which scientific problems we're going to attack. which solution we think is the more elegant one, and thus I'm going to spend 3 years trying to make it work. And when I finally decide, no, it doesn't work, how do I decide, one more month of work and maybe I'll get there, or not? Our faith, whether we think we have it or not, is what controls the science we choose to do and the way we choose to do the science. Somebody at lunch was asking me if I'd known Carl Sagan. Of course, we were contemporaries. We knew each other. Carl never claimed to be a person of faith, though he also said once that an atheist is somebody who knows more than I do. He would call himself an agnostic. And yet, he would never fake data to make himself look good on the theory that no one's going to find out till I'm dead. That's not how you do science. Because if it's not true, then it's not worth doing. In other words, truth was more important than, looking good in public. And I would hope most scientists would think that, especially in astronomy when there's no money to be made. But think of what a remarkable thing that is, to say that truth is my God, that truth is a transcendent, bigger than my day-to-day worries and woes. How can you tell me he doesn't believe in God? He believes in truth, even knowing that he'll never have it perfectly. And he believes in truth so that he will never be satisfied with anything less. That is a religious point of view, whether you want to call it that or not. I showed you those wonderful telescopes in Rome, but of course light pollution eventually did us in. So in the 1980s, we joined with the University of Arizona, finding a mountaintop in the dark skies practically into New Mexico, and built this wonderful telescope. I could talk for hours about the telescope. I won't, except to say it's a fabulous mirror made by a guy named Roger Angel at the University of Arizona. Yes, the Pope has a telescope with a mirror made by an angel. We cooperate with the University of Arizona. We have summer schools with students from around the world, Catholic and non-Catholic. We're members of the International Astronomical Union. In fact, the fellow in the middle there, Father Chris Corbally, he's the guy who wrote the definition for what is a planet. It did not demote Pluto. If you use the word demote, you're somehow implying that being a planet is better than being some other kind of interesting object. And as someone who studies asteroids and dwarf planets, I take great offense at that. You're guilty of planetism. The point is, as members of the Vatican city-state and their national observatory, we are representatives of a part of the astronomical world. The work that I do is just one of a dozen astronomers coming from 6 nations, 4 continents, all of us with PhDs from some of the biggest schools in the world, Oxford to Arizona to Toronto to the Charles, studying things from quantum gravity to information theory to meteors. Bob is involved in the NASA Lucy mission, and also he's now making measurements of the samples that came from asteroid Bennu that NASA brought back. He's making those measurements not because he said, ooh, let me, but NASA came to him and said, you're the best in the world at this. Can you help us out? We have a laboratory in Rome where we still work on meteors and meteorites. Pope Francis, who's got a background in chemistry, as you know, and when he showed up to our lab, he wore this nice white lab coat. So the science that we get to do at the Vatican Observatory today is sometimes called orphan science. It's a science that nobody else will pay for. Because doing the measurements of meteorites and asteroids that I do took 10 years to come up with a database that was worth publishing. Back in the days before I was a Jesuit, when I was being paid on NASA grants, the grant runs out in 3 years. If you don't have a project, that can't produce results in 3 years, you're not going to get your grant renewed. If you don't have a project that doesn't get results in 6 years, you're not going to get tenure. But I didn't have to worry about that. My assignment when I arrived at the Vatican Observatory, the same thing I tell new scientists when they arrive now that I'm the director. Your job, do good science. Let us know when you got something. Until then, do what you think is the right stuff to do. We wind up doing the kind of science that the rest of the field needs. We collaborate with the rest of the field. We're on the same committees. We publish papers together. We're in the same organizations. 20 years ago, they elected me the president of the Division for Planetary Sciences of the American Astronomical Society. And next year, I'll take over as president of the Meteoritical Society, which studies meteorites. I think maybe we get elected to these things in part because we're not competing for money with all these other people, and they figure we got the free time, and they're right. But it's also because we're scientists, fellow scientists, alongside other scientists. The one thing that I make sure is that, you know, if we are to be the living example that science and faith work together just fine, you can't be a weird kind of scientist, and you can't be a weird kind of Catholic. So we're pretty orthodox, we're pretty ordinary. And that's fine because I'm not out there to, you know, get a Nobel Prize or get my name in the paper. I'm there to do the science. And I'm there to do the science because it's fun to do. And it's fun to do because the joy you experience when you do the science, to me, is the presence of God. And I've been rushing because I've got a little movie that runs 6 minutes, and then we can open it to questions. Both science and religion are conversations about the universe. They're ways of learning how we interact with this universe. It's not simply a question of, is there a God, but there is a God, now what do we do? It's not just a question of, there are a bunch of stars, but rather, why are there stars? How do they work? How does that tell us how things work here on Earth? The interaction that I see in my own life is that religion gives me the reason to do the science.
Back in the papacy before Francis was Benedict, and one of his lines in a final elocution to the fathers of the general congregation was, go to the frontiers. Well, there isn't much more frontier than 3.7 billion years away.
The first official interest of the Church for astronomy started in 1582 with the reform of the calendar. Then in 1891, Pope Leo XIII wanted to have an observatory to show that the Church is not against science, but the Church promotes good science.
They start out by having telescopes on the Tower of the Winds, and then on the walls surrounding the Vatican, as the city lights grow, and as the Italian government gives them back the territory out in Castel Gandolfo. In the 30s, they build new telescopes on the roof of the Papal Palace in Castel Gandolfo. Best telescopes of their era in the 1930s. By the 1980s, light pollution makes those telescopes unusable, so we build a new telescope in the dark skies of Arizona.
I'm Father Jean-Baptiste Kikwaya Eluo. I'm working in 3 projects. The first one is NEOS, Near Earth Object. So what I'm doing with NEOS is just observe them using our modern telescope VAT. The second project is meteors. I worked on a very faint meteors, what we call shooting stars. And the third project is set fireball network. They will have 4 cameras here around Tucson so that actually we can monitor any fireball getting into the Earth atmosphere in the region. This
telescope, the Vatican Advanced Technology Telescope. It was the first of the new technology telescopes that has been considered pretty much the norm now in developing telescopes. With the advance of computer technology, we have the capability of bringing that advanced technology directly into our telescope. So it's an expandable, it's almost like it's a living machine, so it can grow as technology grows.
It is still very important to maintain scientific research at the Vatican, simply because there is still a lot of confusion about this relationship between science and faith. We are not out here trying to prove the existence of God by looking through a telescope. That's not what we're doing. But we can say that if we want to obtain any reasonable results looking through that telescope, we need to do it embracing a certain work ethics that is, in fact, the same work ethics that the Bible itself tells us through commandments and through the Gospels to embrace.
Human beings look at the stars and wonder. They want to know, what is that? What is that about? How do I fit in? They hear about the moon landing and they want to know, what was that like?
Very well.
If we're part of the human race, we're part of the race that went to the moon. We're part of the species that looked at the stars and wondered, what the heck are those things? Looking at the sky reminds you that there's more to the universe than what's for lunch. What's more, if you believe in a universe that God so loved that he sent his son, then not only are you going to want to study the universe because it's kind of cool, it's an act of worship. It's an act of getting closer to the Creator and getting closer to a universe, as St. Athanasius said 1,500 years ago, was cleansed and quickened by the Incarnation. Then, doing science is an act of worship. Thanks a whole lot for coming.
I want to tell folks about what we're going to do now. We have about 15 minutes for questions, and ideally it'd be nice to hear from a few students. But then we also have time to, if you want to meet Brother Guy and chat with him for a little while, we have a reception in the Jepson Lounge, which is up the stairs and at the end of the hallway. So we have several opportunities for you to interact with Brother Guy, but for right now, about 15 minutes of questions, and I'll let you field questions. Yeah,
right.
Field and respond.
Feel free to ask anything you want, like, what does the Pope have for breakfast? I have no idea. And we'll go from there. Yes?
Can you talk a little bit about your research?
My research. I started out doing theories, making models for how the moons of Jupiter might melt if they're a mixture of rock and ice. And to do that, I needed to know things like, how well does the rock and ice conduct heat. And to do that, I needed to know the thermal conductivity and the density of the rocky stuff, which I assumed were meteorites. And I discovered back then, nobody had ever measured them. So I made up some numbers and turned in my thesis and went merrily on my way. But 20 years later, I'm at the Vatican Observatory with a collection of 1,000 meteorites. And I realized this is my chance to make the measurements. So in fact, we've started a systematic measurement of not only density and porosity, but also thermal properties, including coefficient of thermal expansion. One of the things we discovered is that the stuff that asteroid Bennu is likely made of, similar to CM carbonaceous chondrites, will shrink when it warms up at 200 Kelvin because of the OH molecules changing their modes of vibration. And that could explain why Bennu has such a soft surface, because it has fluctuated through that temperature point every time it spins, every time it gets closer and farther from the sun. So what started as rocks are probably highly fractured. And it's just an example of how a measurement made in the lab can turn into a measurement that has real-world effects. So the physical property of meteorites is kind of my thing. Yes?
What are some other examples of projects that the Vatican Observatory takes on that would be considered profitable scientifically?
Right, well, there's one, you may remember Hubble had this deep field where they looked at galaxies at an enormous distance, which is to say, at the beginning of the universe. All you could really tell is the shape of the galaxies. So what can you learn from the shape of the galaxies? Well, are they similar to the shapes of galaxies much closer to us? Nobody had ever done that kind of measurement before. So we used our telescope, which was ideal for it, to look at several hundred galaxies at the same resolution as the galaxies that Hubble saw, to try to make a comparison. That's one example. When the telescope was first inaugurated, a group of astronomers at Columbia collaborated with our people. They brought a camera, and they looked at the Andromeda galaxy with our telescope at a high enough resolution such that if the Andromeda galaxy was being orbited by massive compact halo objects, which would be dark but have mass and thus explain dark matter, if that was happening, enough of them would pass in front of a star that that star would momentarily be gravitationally lensed and lit up. So you look for a couple of years, they found just enough of these effects to know that if the effects were there, they would have seen them, but nowhere near enough of the effects to say that nachos actually exist. And that's why nobody talks about them anymore. Basically, our telescope showed that no, we have to come to a different theory. That's two. The work that I did, I worked with a couple of guys just doing an inventory of the trans-Neptunian objects, the dwarf planets and the asteroids out beyond Neptune, just doing a simple sampling of color. Are they reddish? Are they greenish? Are they blue? What's their typical color? We just didn't know. Nobody had ever measured them. They'd only been discovered starting in the 1990s. And we did this work from about 1995 until 2010, and found that actually the trans-Neptunian objects come in two distinct colors. Half of them are a deep red, the reddest things in the solar system, and the other are completely gray, no color at all, and nothing in between. And the red ones turn out to all have the same kind of orbit, and you never find gray ones in that orbit. We're still working out what this means, but this is a step forward in trying to figure out how things turn the colors they are. That's the kind of work that took 15 years. If you were depending on a grant to do, we never would have gotten enough data to do it. So, 3 that come off the top of my head. Yes?
Based on the results of your research, based on those results, do you find that God is sort of leading you to think about certain things about, the existence of humanity or the human existence and there are examples of that? What are they?
Not anything that direct.
Okay.
What I will say comes out of my religious spirit looking at the universe is it's a constant reassurance that the universe makes sense. And that's no small thing. When I was in high school in Detroit, the Jesuit high school there, I learned classics. I learned Greek. They made us, read the Gospel, the Gospel of John, the opening. In the beginning was the word anarchaeologos in the Greek. The Greek word for word is logos, which is also where we get the word logic. You can think of logic as an expression of the second person of the Trinity. A universe that is logical means a universe where I can predict to the second when a total eclipse is going to occur. But this same universe gives me a total surprise at how beautiful that eclipse is. A surprise at how beautiful Maxwell's equations are, and how much delight there is in the understanding of the universe. And this is the way that I get more familiar with God's personality. It was John Neumann who said about mathematics, you never understand mathematics, you just get used to it. And I think that's true of science. I think that's true of the universe. I think that's true of God. You get used to it by spending time with it. And this is how I spend time getting used to God. Yes?
Thank you so much for your talk. I was wondering if you could tell us some of the reasons why that motivated you to become a Jesuit.
I first wanted to be a Jesuit when I went off to Boston College, 1970, more years than I care to think about. And I don't know what students are like today, but I have to confess, when I was a student, there was an awful lot of drinking on campus. I'm sure that doesn't happen anymore. And when especially college freshmen drink, they tend to be really stupid. I mean, we're stupid to begin with, but it just makes it worse. And then they would pour out their problems to me, and I'd think, well, of course you got problems. You're an idiot. What do you expect? I couldn't stand the freshman dorms, so I decided to become a Jesuit priest to get out of the freshman dorms. I was desperate. But not desperate enough, because when the Jesuit I talked to said, pray about this, and I went and prayed, God said, you've got to be kidding me. That's the stupidest reason to be a Jesuit. And besides, what do you think a priest is going to do? Spend your day dealing with people with problems. Because you know, sometimes people have problems when they're not idiots. And you know, sometimes even when you're an idiot, you still deserve to have somebody listen to your problems. And I'm going, but I can't do that. I'm a nerd. And God says, go to nerd school. So I went to MIT and tried school. 20 years later, I was in a completely different situation. I was teaching at Lafayette College and really happy. And I thought, this is where I need to be. This is a principle of Jesuit discernment, by the way. You don't make these big decisions when you're miserable, because you're likely to make stupid decisions. You make them when things are going well, and you can look at the world clearly. And I said, this is great. I love what I'm doing. The person I dated, she broke up with me, and it was the best thing that happened to either of us. It's like, we were not right for you. She was a brilliant, wonderful woman, but just not the right person for me. What am I going to do with my life? I'm now pushing 40 years old. And I thought, well, if only I'd been a Jesuit priest, I could teach at a place like Gonzaga. That would be a blast. And then God said, there are brothers. You don't have to not be a nerd. There is room in the Jesuits for nerds. And I asked all my friends, and they said, well, of course, we all could have told you. And I asked my parents, and my dad said, I could have told you that when you were in high school. And I asked the women I was dating, and said, be a Jesuit. Make some woman happy. Don't marry her. I joined the Jesuits, and it was like the best thing I ever did. This is where I belonged. And after 2 years in the novitiate and 2 years of doing philosophy studies, I'm ready to be assigned to a university. And they say, well, actually, no, we got this letter from Rome. And they assigned me to the Vatican Observatory. It wasn't anything I asked for. It wasn't actually what I thought I wanted. But one of those vows I had to take was obedience. And it's turned out to be great. I've really enjoyed it.
Maybe one more question, and then we'll move to our reception period.
Okay, I've done this side. Anybody on this side has got a question? Going once? Yes.
My physics class was observing the times of the sun rising and setting at the vernal equinox. But we didn't get 12 hours. We had 11:55, I think, on one day, and 12:05 on the next day. And I know the time, the Earth has to rotate.
Yeah.
But it seemed a little bit off, and I couldn't explain it to them why it seemed like we were more off than we should.
Right. It's the refraction of the Earth's atmosphere. You can see the sun on the horizon when in fact it's below the horizon, because the Earth's atmosphere bends the light. And that's why you in fact don't see the equinox being exactly equal day and night. And it works in both directions. That has another interesting effect, which is described in a book I just published, and I'll leave it up there. If you want to know what to do, go to Amazon, find any book with my name on it, and buy 2 copies. Can't go wrong. Thanks a whole lot, everybody, for coming.
Dan, would you escort